Okay, here we are with the compounding interest formula. Now, notice what it says here. Negative values mean that money is leaving your hand, and positive means that it is coming to you. So all of these have values. N is the number of periods. So 20 years with monthly payments, that's N is 240. Make sure you're okay with that. That's not the number of years, that's the number of payments. Interest rate, that is like 7%. You would put in the number 7, not 0.07. Principal value is the starting amount and the payments, either monthly or yearly, and the final amount that comes back. So over here, number 1, N equals 15, so we'd write 15. Interest rate is 7. The principal value is a negative 2,000. Now, negative 2,000, that means you are spending money right now. It's going out of your hand. So this is an investment or a savings account. And then we are not putting in a regular payment. And we want to know what the future value is. Now notice here, this is payments per year or cycles per year, and they're usually the same number. So future value, and that's what we want. So we hit alpha solve. So alpha enter gives us a solve, and this one is at $5,518. Let's put that in there. And be sure to round to the nearest penny. Good. Number 2, you'll notice we go up here and we're just like, oh yeah, look at this. We can do this guy. We go up to where N says 15 and we say, no, we want N as 180. So there are 180 payments going on at a 7% interest rate. Now this is a positive 2,000, which means the person is taking out a loan. Money is coming to them. And we want to find out what the future value is. And this is a 12. So this is a monthly payment. And you can see that changed it right there. So we want to know what the future value is. So we go up to the future value and hit alpha solve. And it's negative 56.97. Now that's interesting. That means if you took out a loan for $2,000, you would have to, at the end, instead of making monthly payments, you'd have to pay back this much money at the end of 15 years at that amount. Let's put it in, negative 56.97.89. Good. Number 3. We'll punch in these. Now look at this. This one actually has a payment of negative $50. So you're going to make a payment over the course of every month for it looks like 20 years at a 6% interest rate, and we'll see how it grows. So it's actually a pretty neat little app to be able to punch in almost everything. So let's go up here to the N is 240. You just punch it in. Interest rate is now 6%. The principal value is at 0, which means we're not starting with any amount of money, but we are giving away or investing $50 a month and 12 times a year. We already got that. Future value, alpha, solve. You will save over the course of that 20 years $23,102. So 23,102 and 04. That's pretty cool. All right, next one. Number 4. Ooh, this is a good one. This is saying, let's start from the bottom up. Payments per year is 12. The final value we want to be 9,000. The payment is negative 30. So what this means is we want $9,000 to be in our account to come back out to us. We're going to make $30 a month payments. The interest rate, ooh, that's a good interest rate. Look at that. We're starting off with negative $200. That means we've invested $200, and it's a 9.2% interest rate. And now when we hit solve, it's telling us we need 149 months of that, of $30 a month, having started out with $200, and to end up at $9,000, we need 149 months, or almost 150. So 149.8 months, which just over 12 years is how you'd be able to make $9,000. All right, number 5. We have 360. That's 30 years at a 5.2% interest rate. The principal value is 120,000. Good heavens, who would take out a loan for 120,000? Oh, this looks like a 30-year mortgage. The payment, we don't know what the payment is. The final value is 0. Now this is the setup for a mortgage because you're starting out at such a high number coming to you. You're paying on it for 30 years and you want it to be zeroed out. So you're saying, okay, what payment do I make on a monthly basis, 12 down here for that. And you just hit alpha, solve. Oh my goodness. It says that money has to go away from you at the rate of $658.93. So $658.93. And that will be your mortgage payment. Okay, number 6. So N is 240. Stick in 4.3% interest rate. And, ooh, we don't know what it is. This is a question would be, okay, we can afford $700 a month for our mortgage. How much of a mortgage can we get? So what is the principal value that we can pull out? Alpha solve. You can pull out $112,000, and this is at a 20-year loan. So you could actually buy a house for $112,000. That's 112,557. 0.45. That's how much of a house you could buy. Okay, number 7. We don't know what N is, but we are, the interest rate is 7.3. The principal value is 25,000. Ooh, maybe an expensive car or something like that. And we can only afford $300 a month to pay for that car. Ooh. Note that they changed that P over Y to a 4 down here. That means you're paying quarterly. So in this case, you have $25,000, looks like was coming out to you, and you're paying it off at $300 each quarter, not each month. Okay, so we're looking to see how much time it takes to pay it off right there. Alpha solve. Ooh, now what you look here is this says error. It didn't happen. Wow, if you only pay $300 4 times per year, this money is growing faster than you're paying it off, so it never happens. What a pity. But that's what happens on the calculator if that happens. So, let's try the next one. Let's quit out of that guy, go back into our finance app. All right, so N is 360. Interest rate, that's our question mark. We don't know that guy. So let's go down to, oh boy. Let's go down to principal value is $145,000. So we're getting a loan, that's positive, it's coming to us. The payment is negative $790. That means we're making a payment on that loan. The future value is we're going to pay it all the way off, and we have 12 cycles per month. So let's go up here and alpha solve. Looks like this will happen. We'll pay it off in 30 years at 5.13% interest. And that's how you do these compounding interest formulas. You get your calculator out and have a blast.